We have done recap on all the equation that we learned for this. We continue from example number 2. Now, recall that for rigid body, we have 3 types of motion: translation, rotation, and general plane motion. Okay, translation, you have 2, rectilinear and curvilinear translation. Okay. Now, we are looking at general plane motion. When you at absolute motion analysis, so when we have a general plane motion, means that we have a combination of translation and rotation. Let's say we look at this diagram. So this diagram, this object is having 2 types of motion. So when you do analysis, you split them into 2 components. One is translation, one is rotation. So you know that previously you learned that V equal to ds dt, A equal to dv d theta, omega equal to d theta dt, alpha equal to d omega dt. Okay. All right. Okay. So this is a truck, a dump truck that the dump bin can be rotated, right? So it's rarely seen in Malaysia, but if you go to Europe, this is quite common. So how this dump bin move? So initially the dump bin will be here, and then okay, the link will be A, B link. This one piston, and second piston, and this is the linkage of A and C. So initially the bin will be this location. Then B will extend. So when B extend and A also extend, the bin will move up and then turn. Okay. So when C extend, S parameter will extend. B fix, A will also sometimes extend. Okay. So you need to recall what the cosine rules that you learn. So for angular or for rigid body, go home and recall what is cosine rules, where you no longer have a right angle triangular. So c square equal to b square plus, sorry, b square equal to a square plus b square minus 2ab cos theta. So a, b, c. So you need to find all these with cosine rules. So you have the length of all these and so on. So I assume you already know, so I don't need to go in cosine rules. So let's look at example 3. So there's a rod here with a spring attached to a disc. So this disc give you a few points. And by looking at the diagram, you know you've seen omega, you see alpha, you see A, you see R. This one is chapter 5 question. So end of rod R maintain contact with the cam by means of the spring. So this one will push on the cam or the round body. If the cam rotates about the axis passing through point O, okay, so this one, if the cam rotate about an axis, pass through point O with the angular acceleration alpha A, so it means this one will rotate. Okay. Determine the velocity and acceleration of rod when the cam is in arbitrary position theta. Okay, you need to find the velocity and acceleration of the rod, which is this one, when the cam is in position theta here. So you derive by starting your position Okay, so coordinate theta and x chosen, and so on. So the cam, this rod is moving in a rectilinear translation motion. So you can use trigonometry relationship. So R is R, sorry, CO or OC will equal to R cos theta. Make sense? What is X? Huh? Nico, what is X? You have OC. You have BC. What is X? Huh? Yeah, OB, yeah. Link X in terms of R and theta. You understand what I want? OC, what is OC? How you calculate OC? R what? R cos theta. Then you have OC, CB. Huh? So what is X? 2OC equal what? I asked you to link with what? I want to see what your answer is what? R and theta. So X equal to R cos theta. You understand what you are saying now? Your X equal to R cos theta. What is OC? How come your X is R cos theta? How come this length will equal to this length? Explain to me. Huh? So what is the answer? Answer is 2R cos theta. Oh, this is basic mathematics, man. Okay. So you know your X, then you need to use chain rules. V equal to dx dt, mean this is a change of X. So what is your X? S is 2R cos theta. Use chain rules in calculus. So if you forget, go home and do your revision. You'll get this equation. Then you arrive at V equal to minus 2R omega sine theta. Again, in your assessment, chain rules won't be given in the question paper. Your A equal to dv dt. Again, you do chain rule again. What is constant here? Negative 2R. Okay. You pull this one out. This is U, this is V. Do chain rules. You get a long equation. Okay. So you will get this equation. D omega dt linked with what? Omega is velocity. What you get? You get acceleration. This one, d theta dt, velocity. So you get this one to alpha, this one to omega. So omega, omega, omega square. Okay, then you rearrange, you get A. Okay, so y negative It's because V and A are opposite of direction of S. Your V and A, your V negative, A also negative. Okay. So, okay. Let's look at example 4. Example 4, this diagram, the blue color is a window. So if you stay in the apartment, the old design, you have a piston that you can just open the window, push, right? So this green color piston will extend and push on pin B, and this window will open, right? So initially this one was here and then it opened. Theta, you see the arrow is positive anticlockwise. You're given the length between O, A, B, and B, O. You see this triangular shape. You don't know whether it's a right angle, so you need to recall cosine rules. Okay, so OB was given, BA was given, AO was given. All the side was given. Theta you can find later. So again, cosine rules apply to this case. All right. So the window is means the length is 2, but B pin is at the center of the window. All right. So large window is open using hydraulic cylinder AB. If the cylinder extended to a constant rate, 0.5 meter per second. All right. So always be sensitive to the wording used for chapter 5 onwards. Here, you are seeing velocity. Don't confuse velocity and angular velocity. It's a different thing. So determine the angular velocity and angular acceleration of the window at the instant theta equal to 30 degrees. So when this one extends up to 30 degrees, you need to find the velocity, so angular velocity and angular acceleration. Now, before you start, what is the direction of angular velocity for this window? Going right, but what is angular velocity? What is the direction of angular velocity? Huh? Again, when you do rigid body, they no longer straight line already. What do you see? You see angular. What I mean by angular? Huh? What the right hand rules tell you? Your direction either clockwise or anti-clockwise. They no longer go up or go down anymore. Go up, go down is particle chapter. So you look at the example 4. Look at the diagram. The blue color window. What is the angular velocity direction? Huh? Why clockwise? You are closing the window or you open the window? How you open a window? Yeah. What mean by open? What happened to piston? Extend. What happened to blue color body? Again, angular velocity is clockwise or anti-clockwise? Okay. Anti-clockwise. You understand why anti-clockwise? Okay, you open out like that. So same velocity, acceleration, angular acceleration, same direction. Okay. You start with position coordinate equation. All right. So angular, rigid body, our position always use theta. Okay. Extension, you know that is S, this one. So given in 0.5 meter per second. So this is what? This is V. This is velocity. Velocity in this direction. You see, this S push B in this direction. You translate this information, 0.5, into here. You draw a velocity and arrow here. Makes sense. This one push with 0.5 meter per second. Okay. So rigid body, you always focus on one individual component. In this case, what you focus? Focus on piston or you focus on window? You focus on window. Huh? We ask you of window. So focus on window. Don't confuse yourself. Right? Don't focus on A, don't focus on O and other area. Pull the whole diagram, pull object out, draw free body diagram. Huh? Okay, so again, cosine rules. It's important and it's not given in exam. So if you draw this diagram and you compare side by side with cosine rules, S square is here. So S square equal to OA, it is here. And OB square equal to minus OB cos theta. Okay. All right. So I won't go deep into mathematics. Go home and look at the mathematics. Then you arrive at this equation. Sine square, S square equal to 5 minus 4 cos theta. Then what angle you substitute? 30. Substitute here. You'll get 1.2. Typo error, there's no error. Any questions so far? Okay. You do time derivative. Why? Because you want to find velocity. So here, you do time derivative. You time derivative of whole equation. ds square dt equal to dt 5 minus 4 cos theta. You do the time derivative. You'll get 2s ds dt equal this one, constant value 0, and this is the chain rules. You need to apply chain rules. You get this one. Then ds dt equal v, the theta dt equal to omega. You get one new equation. So v was given. Substitute here. Omega theta is here. So you can find omega. Okay. So there's a chain rules here. So dv square, you can write in, when you do chain rules, you can write equal to 2v d tv equal to 2va. Okay. So you taking time derivative again, because you want to find acceleration. So you take time derivative of second equation, right? So, okay, wait now. Okay. Then you do the time derivative. You arrive at v square equal to s. This one change to a. This one change to w, omega square. This one change to alpha. You get one more equation. And acceleration dv ds equal to 0. Because why? Why 0? Yeah, constant velocity, acceleration 0. Vs was given, theta was given, substitute inside, you get your alpha. Okay. So you get negative, the window slow down at 30 degrees. Piston initially very fast, but when it come to 30 degrees, it slow down. Okay. So in coming assessment, you need to describe the motion of rigid body. Okay. Okay, go for relative motion analysis, velocity. You are familiar with this diagram. So we have fixed point, which is x and y at O. And when you have a moving body, we will use x prime and y prime. This you're quite familiar. And if you observe from fixed point to a certain point, you label as R sub something. For example, you're looking at B, you'll be having R sub B. If you're looking at A from fixed point, you write R sub A. And if you're looking at A from A to B, you write RB stroke A. Okay, RB stroke A means distance of B from A. Completing the equation, the vector diagram, what you get? Huh? Which one plus this one equal to which one? Do you know how to completing a vector? Huh? Again? RA plus equal to? Okay. Nico, you pay attention a bit. Pay attention. Nico, what is the vector equation for the one that I draw on whiteboard? So the rest you already know in the previous chapter, right? So this x and y in some textbook we call it absolute position or absolute coordinate or fixed reference, right? Okay, the rest we will look into example. Okay. So position RB is a result plus RB reach the final location, right? So once you have that one, okay, we are looking at this. What we're trying to do now is to explain a translation. Is to explain the translation. So we have displacement. So on this body, AB, after some time, this one this AB, after some time, it reach this location. So A will move in the distance of dr. B will move in the distance of RB. And this is the distance between A and B. So this is RB stroke A means position B from A. So we derive this equation, this diagram, we break this diagram into two motion. One rod AB move to, you focus on point A, you move link AB to this position. This one move to this position. That's why you see there's a dash body here. Then how to reach this position? You turn it, right? You turn it. So there are two motion. One, original to point A, then you rotate at a certain degree. Okay. So, and then you completing the vector again. You have two triangular. You have one triangular and second triangular. What is the first triangular equation? Vector equation for first triangular. A, B, B prime. Huh? Huh? Yeah, what is the equation? Yeah, this is dr stroke B. drb stroke A. So what is your answer? Okay, this one? Okay. Okay. DRBA. You're not understanding what is vector diagram. Go home and read the diagram. Tom, what is the second triangular? Tom, what is the answer? Huh? This starting point, end point. This is resultant. This one plus this one. So, okay, the rest you read now. So you know that this object is having a rotation at point A. So dr B stroke A, drb stroke A is actually, when you learn a quadrant of S and R, S equal to R theta in radian. drb stroke A is your S. This is your R. So your drb stroke A equal to R d theta. So same. Drb stroke A equal to R B stroke A d theta. So actually it's S equal to R theta. Okay. So same displacement of B here to here. So it's the one that you mentioned just now. Okay. Then you substitute the two equation, right? You d something, you will get VB equal to VA, VB stroke A. This one you already know in the previous chapter, right? In particle chapter, right? But now you're looking at rigid body. Okay, the rest you read, huh? What important here is that when you look at rigid body, you need to know how to dissect the motion. You look at the before and after, then you think how it reached from original location to final location. What kind of motion it involves? How you combine translation and rotation. Sometimes it rotate first, then only translate. Okay. The rest is same lah. You read on my slides. Okay. So same with this one. If an object AB or link AB, point A doing circular motion, you know that how to draw VA already, right? On the circular path. It's always tangent to the curve. Same with B. B moving on this path, Y pointing up because it gives you the omega. It rotate this way. So A point this way, B point this way. And the direction always tangent to the curve, right? So you can for general motion of rotate, right, of rotating, is you can combine with translation and rotation to achieve this objective. So point VA both move in the same direction. Why same direction? It's like your eyes and mouth. You move in the same direction. VA equal to VB. Okay. Then you rotate at point A. So point A fixed, B rotate. How to find V? V equal to omega R. Okay. How you find this one? V and omega. V must be 90 degree to this is your omega. Okay. So as you can see here, it's quite direct. Huh? So how to find V? You take omega R. Okay. So you're completing the triangular. Okay. Okay, the rest you read and then cross product. Go home and read how to do cross products. Okay. So if you need to analyze using vector analysis, you need to use cross products. Huh? So VA, VB, V stroke A, you can write in omega cross RB, R stroke B. Okay. Okay, we have a short break here. Later, we will apply example 5. Okay.